In a genetics lab at the University of Leicester, sometime in 2013, a researcher is staring at two DNA readouts sitting side by side on a screen. They should match. They don't. A year of work has just gone into proving that the skeleton pulled out from under a city car park belongs to a king, and the very same data set that confirms it is quietly pointing at something else entirely. A break somewhere in that royal bloodline that nobody in the room expected to find. This is the number that anchors everything you're about to hear. 99.999% certain that this is Richard III. And buried inside that same statistical model is proof that somewhere along his family line, a child was not who everyone on paper assumed. For centuries, this was the one thread of royal genealogy that historians and genealogists alike tended to leave alone, because pulling on it meant questioning the legitimacy of names that entire dynasties were built on. Over the next several minutes, we're going to walk through exactly where that discrepancy surfaces, why it barely got a mention in the early headlines, and what it actually means for a throne that changed hands more than once on the strength of legitimate blood. Before we get into the part they buried in a footnote, go ahead and hit follow, because finding the sentence hiding at the bottom of the study is basically this channel's whole reason for existing. None of it starts in a genetics lab, though. It starts in a parking lot in Leicester, 3 full years before anyone had the faintest idea what the DNA would eventually say. On September 4, 2012, a small team from University of Leicester Archaeological Services began digging under an ordinary city council car park, working off a theory that this patch of asphalt sat directly over the lost site of the old Greyfriars Friary. Even the archaeologist running the dig admitted at the time that it was a long shot. Church records placing a medieval friary under a modern parking lot is the kind of lead that rarely pans out. It paid off almost immediately. In the very first trench they opened, the team uncovered a human skeleton with a spine curved sharply enough that nobody needed a lab to notice something was unusual. Adding to the strangeness, the exact spot of the burial sat close to a painted letter R, marking a routine parking space. A detail that made global headlines purely because of how uncanny the coincidence looked. Radiocarbon dating on the bones placed them squarely within the correct 15th century window, matching the time frame researchers were hoping for. Stable isotope analysis of the bone chemistry went a step further, revealing a high-protein, high-status diet, the kind associated with nobility rather than a friar or a common burial. Even the grave itself told a story. It was too short for the body it held, forcing the skeleton into an awkward, squeezed position that suggested a hurried, undignified burial rather than a planned royal interment. Every physical signal lined up. The skeleton looked right. It looked royal. But looking right and being provable are two very different standards, and that gap between appearance and proof is exactly where the real work, the DNA work, was about to begin. Shakespeare's Richard III gave the world a hunchback with a withered arm and a heavy limp, and that image is still the one most people carry into this story without ever questioning it. That portrayal was written roughly a century after Richard's actual death, composed under a Tudor dynasty that had every political reason to paint its defeated predecessor as monstrous as possible. The skeleton pulled from that Leicester trench did have scoliosis. That much was undeniable from the moment it came out of the ground. But the leg bones were symmetrical, with no trace of any arm deformity anywhere on the frame. For centuries, historians had argued over whether Richard's supposed deformity was a real physical condition or simply Tudor-era propaganda dressed up as fact, with no physical evidence available to settle it either way. The 2012 discovery represented the first genuine chance in 500 years to test that stage legend against actual bone. Long before any DNA testing had even begun, the skeleton itself was already quietly overturning one piece of that inherited assumption. Confirming that this wasn't Shakespeare's version of the man still left the far larger question sitting untouched on the table. Was this even Richard at all? Proving identity meant tracking down living relatives, which immediately ran into a problem. Richard III left no direct descendants of his own body. Genealogist Kevin Schurer, then professor of English local history at Leicester, took on the maternal side of the puzzle, tracing the line forward through history from Richard's own generation. That chain ran through Richard's sister, Anne of York, stretching down 17 generations to a living descendant in the present day. The paternal side required an entirely different approach. Researchers had to trace the male line descent of Richard's father's family all the way down to Henry Somerset, the 5th Duke of Beaufort, a chain spanning 19 generations. 5 living male line relatives connected to that Beaufort lineage were located, and asked to contribute DNA samples for testing. This marked the first time genealogical paperwork reaching this far back had ever been directly cross-checked against a real DNA result recovered from the person sitting at the very top of the family tree. The maternal side of that comparison would turn out to be clean, consistent, exactly what the records predicted. The paternal side would not hold up nearly as well. Michael Ibsen, a Canadian-born cabinet maker living in London, was identified through Shearer's genealogical work as a 17th-generation descendant of Richard's sister, connected through an unbroken female line. His mitochondrial DNA was compared directly against genetic material extracted from a tooth and a leg bone belonging to skeleton 1. The result came back as a perfect whole mitochondrial genome match, as close to definitive as this kind of ancient DNA comparison can get. A second relative, Wendy Doldig, produced a result with just a single base mutation difference, precisely the kind of small variation you'd expect to accumulate naturally after this many generations of genetic drift. That maternal line match became the single strongest piece of biological evidence tying the Leicester skeleton back to Richard's actual family. Dr. Turi King, leading the genetic side of the investigation, described the case as comparable to the oldest missing person investigation ever brought to a resolution. On paper, at this stage, the maternal half of the identification puzzle looked completely finished, clean, and beyond dispute. The paternal half of that same puzzle was about to break the model wide open. With the mitochondrial side of the case settled, researchers turned to the paternal line, running Y chromosome analysis on all 5 living male line relatives descended from the Duke of Beaufort. Unlike mitochondrial DNA, the Y chromosome passes strictly from father to son, generation after generation, making it a much more sensitive test of an unbroken paternal chain. 4 of the 5 relatives produced Y chromosome types that matched each other cleanly, exactly what the documented family tree predicted. The 5th relative's results stood apart entirely, a completely different Y chromosome type from the other 4. That single discrepancy meant something concrete. Somewhere within the traceable, documented generations of that specific living family, a false paternity event had taken place. Somewhere along that line, a son's biological father was not the man recorded on the family tree. This wasn't a mystery buried in the deep, unknowable past. The distance was short enough that researchers could isolate the break to only a handful of generations, not centuries. What makes it stranger still is that no one on the research team had set out looking for this. It surfaced almost by accident, through what was meant to be a routine control check supporting the larger identification effort, not an investigation into anyone's personal family history. For the 5 living relatives providing samples in good faith, this was the surprise waiting inside their own generational record. But the far more significant discovery wasn't sitting in the living family at all. It was sitting in the bones themselves, still waiting to be compared. That comparison came next, when skeleton 1's own Y chromosome was measured against all 5 living relatives, and it matched none of them. This wasn't the kind of near-miss researchers had seen on the maternal side, where a single mutation still counted as a match within expected genetic drift. This was a clean, complete non-match across the board. The implication was harder to explain away than the earlier discrepancy. A false paternity event had occurred somewhere along the full 19-generation stretch separating Richard III from Henry Somerset, the Duke of Beaufort. That break could have happened centuries after Richard's death, or it could have happened much closer to Richard's own era. Researchers were careful and precise on this point, stating plainly that they could not identify where within those 19 generations the actual break occurred. The practical effect was strange to sit with. Richard's Y lineage could technically still be traced backward through history, stretching into deep prehistory along the male line. Forward, through the specific aristocratic chain connecting him to the Beaufort family, it simply didn't hold. What had looked, from the outside, like a tidy confirmation of royal bloodline suddenly carried an asterisk none of the early headlines mentioned. A missing person's case built on genetics doesn't usually end up reopening questions about the integrity of an entire royal family tree, yet that is precisely where this one landed. The reason this detail carries weight beyond a single family's paperwork comes down to how English royal succession actually worked for centuries. Claims to the throne rested overwhelmingly on documented legitimate male line descent, not on maternal ancestry. If a false paternity event occurred anywhere between the era of Edward III and Richard III's own generation, the consequences would not stop with Richard. They would extend to the legitimacy of the entire Plantagenet claim to the crown. Science coverage at the time noted that the uncertainty could theoretically stretch even further, touching descendants such as Henry V and Henry VI. The implications don't stop with the Plantagenets either. The House of Tudor's own bloodline claims leaned in part on descent from that same broader medieval nobility, meaning the discrepancy brushes up against Tudor legitimacy as well. None of this amounts to proof pinned to one specific generation. The study is explicit and unambiguous that the exact location of the break remains unknown, so this isn't a case of history books needing to be rewritten overnight. Put plainly, the genetic finding simply removes a long-standing assumption, the idea that royal bloodlines were as documented and airtight as the paperwork always claimed them to be. And the lab wasn't finished producing surprises. The next one had nothing to do with lineage at all, and everything to do with what Richard actually looked like. Given how significant this finding was, researchers weren't willing to rest the case on a single laboratory's word. The results were sent abroad for independent verification, a standard step for extraordinary claims. At Université Paul Sabatier in France, Dr. Patricia Ballaresque and Dr. Laure Tonasso reran key portions of the genetic analysis using the same samples and methodology. Their independent work corroborated the University of Leicester's conclusions in full. This cross-border verification step is a major reason this case is so often cited as one of the most rigorously confirmed forensic identifications of any historical figure on record. Combining the genetic results with the genealogical work and skeletal evidence produced the statistical model behind that now famous 99.999% confidence figure. Researchers noted that even applying a deliberately conservative statistical approach, one designed to underestimate rather than overstate certainty, the evidence remained overwhelming. With the identity of Skeleton 1 locked down through two independent scientific channels, the team's attention shifted away from bloodline questions entirely. A different, much stranger question was next. After 500 years underground, what did Richard III actually look like? DNA extracted from the remains allowed researchers to generate predictions for Richard's likely childhood hair and eye coloring, based on known genetic markers tied to pigmentation. Those predictions were then compared against the earliest surviving painted portrait of Richard, itself believed to be a later copy made from a now-lost original. The portrait depicted light brown hair and blue eyes, broadly consistent with the DNA-based prediction of a blonde, blue-eyed childhood that likely darkened as Richard aged into adulthood. Because no portrait survives from Richard's own lifetime, this comparison against a later copy was the closest verification available to researchers. This particular detail carried less weight for the legal question of identification and far more weight for public imagination, giving people something tangible to attach to a name that had, until 2012, existed only in bone and historical record. Separately from the genetic team's work, the Richard III Society commissioned its own facial reconstruction project, producing a three-dimensional approximation of Richard's face that was unveiled publicly in London in 2013. Piece by piece, a face was coming together for the man buried under that car park. What happened to that same face during the final chaos at Bosworth Field was an entirely different investigation, one that had nothing to do with DNA at all. With Richard's identity confirmed and his likely appearance reconstructed, a second major research effort took over. This one focused entirely on how he died. This team drew together the University of Leicester, Leicester Royal Infirmary, and the Royal Armouries Museum, combining archaeology, medicine, and weapons expertise under one investigation. Lead researcher Joe Appleby worked alongside Sarah Hainsworth, a professor of materials engineering, and Dr. Guy Ruddy, a forensic pathologist, each bringing a different specialty to the same set of bones. Their method relied on whole-body CT scans and micro-CT imaging, technology capable of capturing detail on the skeleton far beyond what the naked eye could pick up during the original excavation. Alongside the scans, the team ran tool mark analysis, attempting to match the exact shape and depth of each wound to specific medieval weapon types known to have been used at Bosworth. Their findings were published in The Lancet on September 17, 2014, presenting a full peer-reviewed, forensic reconstruction of Richard's final moments on the battlefield. The researchers described this project as the first time modern trauma forensics had ever been applied this comprehensively to a documented historical battle death, treating a 500-year-old king with the same rigor used in a contemporary criminal investigation. Move from the genetics lab to the CT scanner, and the entire focus of the story shifts, from questions of bloodline and ancestry to the physical, violent reality of bloodshed. The scans returned a precise, chilling tally: 11 perimortem injuries in total, meaning wounds inflicted at or extremely close to the moment of death. Of those 11, 9 were located directly on the skull. The remaining 2 were found elsewhere on the skeleton, one to the ribs and one to the pelvis. None of the 11 wounds showed any evidence of healing, confirming they weren't old injuries carried from some earlier point in Richard's life, but damage sustained in his final moments alive. What struck researchers immediately was the sheer concentration of trauma to the head, rather than any even distribution across the body. 9 wounds to the skull alone is a staggering number for a single individual to sustain. At the same time, the team was careful to note a limitation of working with skeletal remains. This count almost certainly doesn't represent every wound Richard suffered during the battle, only the ones capable of leaving a mark on bone. Soft tissue damage, if any occurred, would have vanished along with the rest of the body centuries ago. Still, the pattern on the bone alone raised an immediate and obvious problem for researchers to untangle. 9 separate wounds concentrated on the head of a man who marched into battle in full plate armor meant one very specific question needed answering. Where exactly was his helmet? None of those 9 skull wounds were consistent with a late 15th century helmet still being in place at the moment they were delivered. At the same time, researchers found no defensive wounds anywhere on the arms or hands, the kind of damage typically left behind when someone raises a limb to block an incoming strike. Put together, these 2 details point toward a specific scenario. Richard's body remained armored everywhere, except his head, at the moment he was struck down. Researchers connected this physical evidence to near-contemporary written accounts describing Richard losing his horse in marshy ground during the battle and continuing to fight on foot before he was killed. Whether the helmet came off during the chaos of that fighting or was forcibly removed by an opponent simply can't be determined from bone evidence alone. What the pattern does suggest strongly is that this wasn't a clean, single duel-style kill. The concentration and variety of the skull wounds points instead toward a sustained assault, likely carried out by multiple attackers converging on him at once. 2 of those 9 head wounds carried more weight than all the others combined in the researchers' final assessment, because either one, entirely on its own, would have been enough to end things. Among the 9 skull wounds, researchers identified 2 specific injuries to the base of the skull as the most probable cause of Richard's death. The first was described as a large, sharp force trauma, consistent with a sword or a long staff weapon, such as a halberd or a bill. The second was a penetrating wound, consistent with the narrow tip of an edged weapon driving directly into the base of the skull. Both of these fatal candidate wounds were located at the rear, lower portion of the head, a detail that carries its own implication about how the final blows were delivered. That positioning suggests the strikes most likely came from behind or from above, consistent with Richard being down, kneeling, or otherwise unable to defend himself in that moment. Professor Guy Ruddy, working directly on the forensic pathology side of the study, stated plainly that these 2 specific injuries stood out as the most likely candidates for the actual cause of death. This physical evidence lines up directly with historical accounts describing Richard fighting on to the very end, surrounded by enemies, rather than falling instantly from a single decisive strike. The skull told the story of a prolonged, brutal fight. One more injury on the skeleton, though, happened only after that fight was already over. A roughly 1.2-inch penetrating wound to the pelvis, passing through the right buttock, was assessed by researchers as most likely inflicted after Richard had already died. The timing of that specific wound lines up with a detail recorded in historical accounts of the aftermath. Richard's body was reportedly stripped, thrown over the back of a horse, and paraded publicly back into Leicester as a display of Tudor victory. A separate cut to the right 10th rib, likely delivered by a dagger strike from behind, was assessed by the same team as peri-mortem, meaning it happened at or very near the actual moment of death rather than afterward. Researchers pointed out that combining the battlefield killing wounds with this later, post-mortem injury paints a fuller picture than any single wound could offer in isolation. It also lines up with just how publicly and thoroughly the Tudor regime wanted Richard's defeat displayed, rather than quietly buried or downplayed. The technique used to make this distinction, determining whether a wound was in PEEP. While one team worked through the wounds themselves, a separate group of researchers, led by Joe Appleby, alongside Cambridge's Piers Mitchell, focused entirely on something that had been visible since the very moment the skeleton came out of the ground: the pronounced curve running through Richard's spine. To study that curve properly, the team digitally scanned the vertebrae and reconstructed them into a rotatable 3-dimensional model, allowing them to examine the true shape and severity of the deformity from every possible angle, rather than relying on a static skeleton laid out on a table. Their diagnosis was adolescent-onset idiopathic scoliosis. The word idiopathic simply means the underlying cause is unknown, which happens to be the case in the vast majority of human scoliosis diagnoses even today. Based on the pattern of the curve, researchers concluded it most likely developed after age 10, squarely within the age range where this particular type of scoliosis typically emerges during growth. To measure the severity precisely, the team used Cobb angle measurements, the standard clinical method doctors still rely on to grade spinal curvature, and Richard's results came back somewhere between roughly 70 and 90 degrees. Researchers went further, classifying the shape of the curve as a King-Mo type 3 pattern, meaning it was well balanced. Despite the severe lateral bend running through his torso, his head and neck remained straight and properly aligned above it. A curve measuring in that range would be flagged for corrective surgery under modern medical standards without hesitation. In Richard's case, it appears to have barely slowed him down at all. Beyond simply diagnosing the condition, researchers worked out what that curve actually meant for the man living with it day to day. Their estimate, without the scoliosis, Richard would have stood at roughly 5 feet 8 inches, squarely average height for a man of his era. Because the curve was so well balanced, and because his leg bones were symmetrical and completely normal in formation, it wouldn't have produced any kind of noticeable limp when he walked. The study also found that a curve in the 70 to 90 degree range wouldn't have meaningfully reduced his lung capacity or limited his exercise tolerance, contrary to what that degree of curvature might suggest at first glance. Researchers even noted a practical, almost mundane detail. A skilled tailor paired with custom-fitted armor could have minimized the visual impact of the asymmetry almost entirely, hiding it from anyone who didn't know to look for it. All of this sits in direct contradiction to the popular image of a hunched, struggling king barely able to function in battle. Historical accounts from Richard's own era actually describe him as an active, physically capable warrior, not a man hindered by his condition. The physical evidence essentially splits the historical record into two separate figures. The real Richard, a man managing a real but largely invisible medical condition, and the exaggerated stage villain constructed roughly a century later for dramatic effect. With the bones having finished telling that particular story, the next chapter of this saga had nothing to do with medicine at all. It became a fight over where those same bones would even be allowed to rest. On May 3, 2013, a group identifying itself as the Plantagenet Alliance, made up of 15 distant relatives of Richard III, filed for judicial review challenging the plan to rebury his remains. Their position was direct. Richard belonged in York Minster, pointing to his lifelong personal and political connections to the north of England, not in Leicester Cathedral, where the discovery had actually taken place. Justice Haddon Cave, overseeing the early stages of the proceedings, reportedly cautioned both sides against letting the dispute collapse into what he described as an unseemly, undignified legal tussle. Press coverage of the standoff quickly gave the case an informal nickname, calling it the Wars of the Roses Part 2, a nod to the very conflict that had ended Richard's life and reign in the first place. By this point, Leicester Cathedral had already begun a roughly £1 million rebuilding project specifically to prepare a tomb for the king, while the city separately moved forward with plans for a £4 million visitor center built around his story. Underneath the public dispute sat a genuine legal gap. The original exhumation license, issued to the University of Leicester, had never actually required any public consultation on where Richard should ultimately be reburied. It was that specific gap in the paperwork that the Plantagenet Alliance argued made the entire process unlawful. 5 centuries after Bosworth, Richard's body had once again become the single object that two very different sides were determined to claim as their own. The High Court delivered its ruling on May 23, 2014, finding that no legal duty to consult had ever existed regarding the reinterment decision, and dismissed the Plantagenet Alliance's challenge outright. With that ruling in place, Leicester's original plans to rebury Richard at the cathedral were confirmed to move forward without further legal obstruction. In their public remarks on the case, the judges acknowledged just how much emotion the dispute had stirred, noting that passions had been thoroughly roused and, in their own words, that much ink had been spilt over the matter. Richard III was formally reinterred at Leicester Cathedral on March 26, 2015, nearly 530 years after his death on the battlefield at Bosworth. With that ceremony, researchers considered the case fully closed, a case they had already described as the oldest solved missing person investigation in the history of forensic science. Every individual strand of evidence gathered across years of separate research, the genetic testing, the genealogical tracing, the radiocarbon dating, and the skeletal trauma analysis, had by then been folded together into a single peer-reviewed conclusion accepted across the scientific community. On paper, in the courts and in the journals alike, the case was closed. The DNA record sitting quietly inside that same case, however, never actually stopped raising questions of its own. Every piece of this investigation, from the trench under that car park to the courtroom 5 centuries later, was built toward proving one specific thing: that this was Richard III, confirmed beyond reasonable doubt, at a stated 99.999% confidence. In the process of proving that single fact, researchers also uncovered something nobody had set out looking for in the first place: that the paternal bloodline connecting Richard to his own supposed living descendants doesn't fully hold up under direct genetic scrutiny. That break sits unexplained somewhere across 19 full generations, and the study itself is honest that it may never be pinned down to an exact point in time. Separately, the trauma study gave Richard's death a fully documented, near minute-by-minute physical record for the first time in 500 years, reconstructed entirely from the wounds left behind on bone. The scoliosis study, working from that same skeleton, quietly dismantled a piece of Tudor-era propaganda that had managed to survive intact for centuries without ever being tested against physical evidence. So the question worth sitting with at the end of all this isn't whether this was Richard III. The identification itself is about as certain as forensic science gets. The real question is this: if a king's own DNA can't fully confirm the official bloodline his own family claimed for centuries, how many other supposedly legitimate royal lines throughout history would actually survive that same test? The bones answered exactly who he was. They never promised to answer who everyone else really was.